Hi, welcome back to Science Magic platform. Today I'm going to continue the third part of first lesson of class 9 CBSE, Matter in Our Surroundings. So we have discussed almost half of the lesson. The first and second part will continue the same lesson. From 1.3, your activity, states of matter. So we have seen all the properties of matter like mass, volume, shape, arrangement of particles, force of attraction between particles, intermolecular space, kinetic energy, can it flow. Then the last three we are going to discuss under this activity 1.3, that is rigidity, compressibility and diffusibility. So all these three terms are very important. In this lesson, you should explain with the help of an example. So what is rigidity means? Rigid. Rigid means the molecules are having one shape that is not able to change. That is called as rigidity. So the rigidity is one of the property all the particles are having. So if one particle is rigid, it is having particular shape and not going to change. Why it is not able to change its shape? If the particles are very tightly packed like solid. If loosely packed, there will be some deformation in the shape. So we'll see one example which is a matter existing in the form of a solid but changing its shape. For example is, I have one rubber band. I'll show you one rubber band here. So rubber band, which state of matter exists? This is a solid form. But here I explain to you, rigidity means it is having one particular shape and not going to change its shape. But in the case of rubber band, it is a solid. It is changing its shape once you stretch it. So do you have some confusion about this rigidity? Once I release this force, it regains or coming back to its original shape. So, if the solid is changing its shape and coming back to its original shape, that is also the type of rigidity. So, here this is a solid. The solid is containing all the particles packed tightly inside, but once you stretch it, it is changing its shape because of the force you have applied and because of the elastic behavior of this rubber material. So this is changing its shape, but it is coming back to its original shape once you release the force. If it is regaining its shape, it is a solid only. So now, if you apply extra force, what happens to this rubber band? It will break off. So you should apply the force, but you should not exceed the force. So that is example for rigidity. Second is compressibility, compression. What is compression means? You are compressing the particles to another one which contains space. I'll explain here. If I am taking one type of matter which contains many spaces between particles, if this is a type of gaseous matter, it contains more intermolecular space because the particles are very loosely packed. Then if I am keeping one more type of gas particles on the top of it. So the first one was the first layer. On the top of the first layer, I am placing the second layer. and giving the compression with the help of pressure. So what happens there? The second layer contains the particles which is going and occupying in these spaces which is left between the first layer of the particles. Right? So this is called compressibility. You are able to compress. This compression happens mainly for liquid and gas particles which contains more intermolecular space. You are not able to compress any solid particle because there is no space between the particles. So this compression, I can give two examples. One is, I am taking example as LPG gas cylinder. If this is the cylinder, how is this LPG packed inside a small container? By the process called compression with the help of pressure. So we are taking the cylinder. Inside the cylinder, the gas is packed. The gas contains many intermolecular space or more space for occupying the particles. So once one layer is packed, here it contains only two particles. This much space is vacant. The next layer, when you are packing, it contains only one or two particles. So after doing this process, we are compressing the gas particles so that one by one it will be occupying to the space which is left between the first layers. So that if we can save the space, we can occupy or fill more volume of gas inside the cylinder. So here compressibility, we can give examples. CNG gas. What is CNG gas? Compressed natural gas, and even LPG cylinder is an example for compressibility. One more example I can give you. Here, actually this is a solid matter, the sponge. So the sponge contains some space left, that is pores left between the particles. These pores are filling with air, right? So here some space is there between the particles, this solid thing. So that space is occupied by air particles. Once I compress it, I should apply more pressure or force. I'm compressing it. I can see it is coming down. How it is coming down? We cannot see the air particles are expelling out because the air is colorless. You cannot make out. It is expelling out. Expelling out means it's coming out from the spaces. When you are applying pressure or you are doing compression, the air particles which is there in the spaces are coming out, making the compression easy or possible. So these three examples you can remember for compressibility. Next one is diffusibility. What is diffusibility? Able to diffuse or able to mix with other types of matter. This happens only for liquid and gaseous matter. Only if there are spaces between the particles, this diffusibility can be explained. How it is? Can you give an example for this diffusibility? We can give an easy example. If you are sitting in a restaurant, very soon you are catching up the aroma of hot sizzling food. Why you are getting that aroma or smell very fast? Because of this process called diffusibility. So once you are heating or cooking the food, once it attains that temperature, it is getting more kinetic energy and the particles will start moving very fast. So, by evaporation, the water will be liberating from the cooking food. That particle will start moving very fast by using that energy, and these particles will be mixed with the air particles. If these are air particles, these are the particles from the evaporated water. So what happens? These two are mixing together. These spaces are occupied by these particles of food. So that, and it is traveling very fast to your nostrils. You are catching up the smell of the food. So that is explained by the process called diffusibility. So these three you should explain with examples and you should understand the principle. So we'll move to the next activity 1.4. Can matter change its state? Can matter change its state? Yes, it can change its states. In the introduction part I had explained the change of state of matter from one form to another. Solid to liquid, liquid to gas, or back to the previous form. So what is called for this process? Solid to liquid? Melting. Or you can call it as one more term, fusion. Then liquid to solid? Solidification. Or you can call the term freezing. Liquid to gas, you can call it as vaporization. Gas to liquid, you can call it as liquefaction or condensation. Then there is one more type of change, direct change of solid matter to gas without attaining the liquid form. The process is called as sublimation. So sublimation is the process direct change of matter from solid to gas form. And the gas back to solid without changing to liquid form, that is called as desublimation, or we can call it as deposition. So I can give an example for this. I am taking one china dish and filling the china dish with ammonium chloride NH4Cl. It is in the crystal form. I am making the powder form, just crushing and making the powder form. Then I am keeping one inverted funnel, the funnel in the inverted form. I am just keeping it to cover this ammonium chloride. Then this opening is closed with the help of a cotton plug. Here I am keeping one Bunsen burner to provide heat. Once I heat, what happens? The ammonium chloride which is in the solid form gets converted to gas form directly by the process called sublimation. So this is released like this. Can it go out? No. It cannot go out. It cannot escape. Why? We have stopped the way. So once it is reaching here, it becomes cool. It is cooling. Because heat is here only. Because of cooling process, what happens? The gas is changing back to the solid form. Changing back by the process called deposition. So you can give an example. Ammonium chloride or camphor is an example for the sublimation process, and deposition you can give ammonium chloride as an example. So the next one is effect of change of temperature. Is the first activity given under 1.4, effect of change of temperature. Here you have to study new terms. So what are the new terms you are going to learn here? I told you here the solid is changing to liquid form. This process is called melting. And this liquid is changing to the gas form. What is called for that process? This is called boiling. When we are boiling, the liquid is changing to gas form. Right? So this process happens by boiling and it is termed as evaporation process. So once this happens, we can note down there is particular temperature at which this melting or boiling happens. We are taking one example for ice changing to water. The water changing to steam or vapor form. So here when the ice is changing to water at particular temperature, what is called for that temperature? Melting point. So you can call it as MP, melting point. The temperature at which the solid form of matter changes to the liquid form. That is called as melting point. So what is the melting point given for ice? 0 degrees Celsius. We can use the SI unit of temperature Kelvin for this. So 0 degrees Celsius is the melting point of ice, that is expressed by 273 Kelvin. Actually it is 273.15. We are not using decimals, we are using 273 Kelvin. What is the temperature for boiling point? BP. For boiling point at which the water is going to change to the form of a steam. The temperature is, you all know what is the boiling point of water? 100 degrees Celsius. So 100 degrees Celsius, how are you going to convert into Kelvin form? By adding 273. So it is equal to 373 Kelvin. Kelvin is the unit expressed with the first letter K, capital K. So like this we can understand the process of change of matter from one form to another. And there is one more term. It is called latent heat. What is latent heat? Latent heat. What is latent heat? This change of solid to liquid, we are calling it as melting or fusion. So latent heat of fusion for solid to liquid and latent heat of vaporization for liquid to gas. So what is this term latent heat? Once the temperature is reaching near the melting point or boiling point, some amount of heat is absorbed by the particles of that matter to get rid of the force of attraction among the particles. They all are tightly packed in the case of solid because of the force of attraction. To relieve that attraction, it requires some force that is taken from the temperature. So that much energy is required for relieving that force. So once you increase the temperature, it will not be notified that increase. It is keep on increasing, but after reaching its boiling point or melting point, it is not at all increasing very fast because that heat is absorbed by the particles to get rid of this force of attraction between the particles. So that is happening. So the amount of heat absorbed by the particles to change 1 kilogram of the solid matter into the liquid form at atmospheric pressure at particular melting point. That is called as latent heat of fusion. The same way we can explain latent heat of vaporization by using the amount of heat absorbed by the particles to change the state of matter from liquid to gas at particular boiling point. Like this we can explain latent heat of fusion and latent heat of vaporization. So here the next one is effect of change of pressure. What is the effect of change of pressure? I can show you one activity. Is there any effect with the help of pressure? Yes. We are taking one cylinder. So the cylinder contains the particles which are very loosely packed. I am using one piston to apply the pressure. With the help of this piston, I am compressing these particles so that these particles will move and occupy the space which is left between these particles. So there is some effect of change of pressure to compress or pack these particles. right? So one example I can give you, dry ice. What is dry ice? Solid form of carbon dioxide. We are taking carbon dioxide gas. This gas can be changed in the form of solid form by this process compression. We are compressing it so that the solid form is attained. It is compressing into the form. It is called as dry ice. So these many things we have explained under 1.4. Can matter change its state? The first one is effect of change of temperature. Second one is effect of change of pressure. So we have reached the last topic of this lesson, evaporation, the process of change of matter from the liquid form to gaseous form. That is called as evaporation or vaporization we can call. So the process by which this happens depends on 4 factors: increased surface area, increased temperature, increased wind speed, and the last one is decreased humidity. The first 3 are increasing and helping for evaporation process. The last one is decreased humidity is helping for evaporation. So we have to remember all these 4 factors. Now I will explain one by one. Increased surface area. So the area is increasing. It is helping for evaporation process more faster. For example, drying clothes. If you are not spreading the clothes properly for drying, it will take more time for evaporation. If you are spreading it, you are giving more surface area so that all the liquid particles can evaporate easily. That is called the first one, increased surface area is helping for evaporation. Second one is increased temperature. Once you give more heat, the temperature is increasing, the particles are gaining more kinetic energy, the movement will be faster. That is second one. Third one is increased wind speed. The wind speed is making the water particles which is evaporated out is moving faster. So water is getting evaporated and changing to the form of vapor. It will be moving fast with more wind speed. The last one is decreased humidity. Humidity means the amount of water vapor present in the atmosphere. For example, if this is one room, here we can occupy 100 particles of vapor. The 100 particles are formed by the process called evaporation. These 100 particles are occupying this space. Again, can you expect evaporation happens if you give more heat? No, because there is no space for occupying the upcoming particles. So the process will be delayed or it will take more time to make it. So decreased humidity is helping for evaporation. So if more humidity is there, evaporation process will be slower or not happening at all. If decreased humidity means less amount of water vapor and there are space to occupy the more upcoming particles, so it is favoring the process of evaporation. Then next activity is 1.5.2, evaporation cause cooling. So once the evaporation happens, once the liquid form is changing to gaseous state, the cooling happens. How it is happening, I will demonstrate. We can give examples: acetone, then sprinkling water on terrace on hot day to make it cool, or cotton clothes. The first one I will demonstrate now. So I have acetone here. If I am pouring some acetone to my palm, after some time what happens? This acetone will be liberating and changing to the form of vapor or gas form, and it will be disappearing from my palm. That is called as vaporization process. So once this is liberating, I am having some cooling effect here on my palm. What is the cooling effect? This is happening when the particles are having the boiling point, that is latent heat of vaporization. Once this energy is utilized for vaporization process, the particles will try to gain energy from the surrounding place. So this is liberated. This is liberated. It was hot here because of my temperature. It was hot here. Once this is releasing, the same time it will be trying to get some energy to regain its energy. It is collecting energy from outside particles of the surrounding place. So that cooling effect is coming to my palm. I am having cooling effect. Now it is disappeared because it is changing to the form of vapor. So this cooling effect is because of this latent heat of vaporization. So the energy which is equal to latent heat of vaporization, once the particles are gaining, the cooling effect comes. Next is, here I wrote terrace. That means hot day. If it is wet summer season, sometimes we can see the people are sprinkling water on the terrace to give cooling effect inside the room. This is also same principle what I explained. The energy which is lost because of evaporation is gaining back from the surrounding place, is giving cooling effect. Third one is cotton clothes. We are suggested to wear cotton clothes during summer because it is having the principle behind this is it is liberating heat by the process of evaporation and gaining the energy from the outside particles, giving you cooling effect. So this is about evaporation. What are the 4 factors and how is evaporation is related with cooling and latent heat of vaporization. So we are finishing this lesson today. Hope you understood. Bye.